This video on the microscope lab will cover how to calculate the magnification of the objective lens using the linear magnification equation, and the magnification of the eyepiece lens using the angular magnification equation, and finally the magnification of the overall microscope. So the question down here, number 10, asks you to calculate the linear magnification of each of your scope lengths. So in this lab you had a microscope with two lenses, and you extended that microscope so you have 3 different lengths. So you will do that calculation and then put the answers here in the table 5. So how are you going to calculate those 3 linear magnifications of your objective lens? We're going to cover that now. Okay, from the equation that is listed in question number 10, you see that the linear magnification M sub L equals negative I, which is the image distance, divided by O, which is the object distance. You can also find the linear magnification by finding the height of the image divided by the height of the object. But we don't know the height of the image or the height of the object. So, I'm going to do this in red. So we don't know that. So we have to use this equation. Okay. So from the lab, you have put your experimental data here, and you determined your objective distance right here. And you also calculated your real image distance there. So for our calculations here, I'm going to use a set of data so that my scope length is going to be 30 centimeters. And then my object distance is going to be 6.9 centimeters. So, and my focal length, by the way, I'm going to use, just like we did before, 5 centimeters. So, just really quickly, when I do 1 over F equals 1 over I plus 1 over O, I'll go 1 over 5 equals 1 over I minus, or plus, sorry, 1 over 6.9. And then doing that, my I will be 18 centimeters. So I is 18, and O is 6.9. Therefore, when I use the linear magnification equation, the linear magnification of my objective lens is minus I, 18, over O, which is 6.9. So when I calculate my linear magnification, that's about 2.6, and it is magnified, so I'm just going to drop the negative number there, 2.6 times. Next is the angular magnification of the eyepiece lens. So the equation for the angular magnification of the eyepiece lens is M, I'm going to say EP for eyepiece, equals 25 centimeters over the focal length of the eyepiece lens. And I'm going to just use as focal length of the eyepiece lens equals 10 centimeters. So that you would have to either determine that or it would be given to you, the focal length of the eyepiece lens. So 25 divided by centimeters divided by 10 centimeters equals 2.5. So my eyepiece lens magnifies 2.5 times. And lastly, for question number 12, the calculation for the overall magnification of your 30 centimeter microscope. So all this data is just for the 30 centimeter microscope, is the magnification of the objective lens times the magnification of the eyepiece lens. Okay, so that is 2.6. We got up here, 2.6 times 2.5 we got for the angular magnification, and that equals 6.5 times. So our overall magnification of our microscope is 6.5 if these were the data that you got. So for the 30 centimeter microscope, or our first microscope, that is how to calculate the answer to question number 10, which was for the linear magnification, or the objective lens magnification. So we put that here. And then the eyepiece magnification, which all three of these numbers would be the same. And you put that in table 6 for question number 11. And then finally in table 7 for question 12, you would put the final answer of 6.5 times in the first box. You would then repeat the same calculations for the 35 and the 40 centimeter length microscope. And you would have all of those questions completed. Hopefully that was helpful in knowing how to calculate the magnification of the two lenses and the overall microscope in your compound microscope.